Last week, we took a look at finding the vertex in vertex form, and when we dealt with factored form, we dealt with sketching an idea of what the graph would look like. This week, we want to actually see specifically what that graph really needs to look like. So what we're going to do is we're going to work on finding the vertex in factored form, as well as the axis of symmetry. If you recall, the vertex is that turning point of a parabola. It's that ordered pair xy at which we change directions from either decreasing to increasing or increasing to decreasing. And that axis of symmetry is going to be that imaginary line that divides the parabola into two equal halves. That's the line I encourage you guys to draw in when we were sketching out the graphs last week. And that the x-coordinate of that vertex, which is the vertex that we're talking about right here, that x-coordinate is going to be written as x equals, and that is the equation for the axis of the line of symmetry. So let's take a look at a couple of examples. Our first example, we want to determine the vertex of the quadratic function and write the equation for the axis of symmetry. Our equation is y equals x minus 3 times the quantity x plus 1. And our first step in this process is going to be to determine the zeros. Now, if you recall from last week, which you should, that's where we say y is going to be 0. So therefore, by the zero product property, either 0 equals x minus 3 or 0 equals x plus 1. Now, when we solve these for x, we get x equals 3 and we get x equals negative 1. So when we write these in as our ordered pairs, we get 3, 0, and negative 1, 0. The next step, once we've got our zeros, this time is going to be to find the average of the zeros, which is the middle of the parabola. So I see here that I've got an x value of 3 and an x value of negative 1. Now, if you recall, finding the average is adding up your values and dividing by how many there are, which in this case is 2. 3 plus negative 1 is 2, divided by 2 is going to be 1. So our line, and so we have here that it's 1. And so we got this value, which is really where that line is, that center is going to be between the two. And what we want to do is we want to substitute the values, for the value from step 2, which is 1, back into the equation to solve for y. So I'll back up again so we can see. So we've got y equals 1 minus 3 times 1 plus 1, because we got that x equals 1 right here. So that means we have y equals negative 2 times 2, which equals negative 4. So that final step is going to be to write that as xy. So our vertex, therefore, is going to be 1, negative 4, because our x value is going to, x coordinate is going to be here, which is this right here, and this is going to be our y. Now that we've gotten our vertex of 1, negative 4, now we need to find that axis of symmetry. For our axis of symmetry, this is very simple. We're going to take the x coordinate, which, as you can see, is 1, and we're going to write that vertex, point from the vertex, as x equals, so x equals 1. Now, for today, we're not going to deal with graphing. We'll get into that tomorrow. So we've got our vertex of 1, negative 4, and our axis of symmetry of x equals 1. Let's take a look at a few more examples. So for B, y equals the quantity, 2 times the quantity x plus 4 times the quantity x plus 6. So first, we're going to start with our zeros. And so I know that 0 equals x plus 4, or 0 equals x plus 6, which means that x equals negative 4, or x equals negative 6, which means my zeros are negative 4, 0, and negative 6, 0. So then we average those. And so -4 plus -6, divide by 2. -4 plus -6 is -10, divide by 2 is -5. Then we're gonna substitute that back in to get our y value. So in our original equation, we get y equals 2 times -5 plus 4 times -5 plus 6, which is equal to 2 times -1 times +1, which equals -2. So therefore, I'll put this in a different color so you can read it better. Our vertex is equal to x value of -5, y value -2. And for our axis of symmetry, we're going to take our x coordinate, which is -5, and we get x equals -5. Moving on to the last two examples here before we end this video. We've got zeros for y equals negative times the quantity x minus 5 times the quantity x minus 7. So we have 0 equals x minus 5 or 0 equals x minus 7. Now I know that this is going to be x equals 5, which means 5, 0. We'll skip ahead since you should be able to get to this point by now. X equals 7, so 7, 0. 5 plus 7 divided by 2. 5 plus 7 is 12. 12 divided by 2 is 6. Put that back in. Y equals the negative of 6 minus 5 times 6 minus 7, which equals -1 times 1 times -1, which equals 1, which means that y equals 1, and my vertex is going to be 6, 1. Axis of symmetry is going to be x equals 6. Last example. Y equals 1/2 times x plus 2 times x minus 8. So 0 equals x plus 2 or 0 equals x minus 8. So x equals -2, so this is -2, 0. And x equals 8, so 8, 0. Then we average them. -2 plus 8 divided by 2. -2 plus 8 is 6. 6 divided by 2 is 3. So now I take y equals 1/2 of 3 plus 2 times 3 minus 8. And we get y equals 1/2 times 5 times -5. Now this doesn't come out very pretty, but it is -12 1/2. So my vertex is going to be 3, -12 1/2 or 12.5. My axis of symmetry is going to be x equals 3. What you need to do now is try the U-try problems, determine the vertex, and write the equation for the axis symmetry. Bring any questions you have to class with you tomorrow.